Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathcook.com. Let's MathCook it up. This question says, find the rectangular equation for the set of parametric equations x equals square root of 2t, y equals negative t minus 3 if t is greater than or equal to 0. Then graph and show its orientation or direction. So there are a few methods to kind of help graph a parametric equation. Here they are. So there's method 1, 2, and 3. Now oftentimes you'll use a combination of these methods to graph a set of parametric equations. So let's take a look at method 1. You're going to make a chart with the parameter and the two functions. So the parameter is t, and as a reminder, the parameter is the variable that acts as a bridge between the two other variables. So in this case, t is in both these equations. See how x is in terms of t, y is in terms of t. So therefore, t is the parameter or the bridge that relates x and y. All right, and then you would graph the points and draw the curve. Next is the second method. You would solve for the parameter, in this case t, in one of the equations, and then you'd substitute into the other equation to eliminate the parameter. And then based on that, you'll get a function of y in terms of x, and then you can graph. Method 3 is using an identity to substitute with parametric equations to eliminate the parameter. Oftentimes, you would use sine squared t plus cosine squared t equals 1. Now in this problem though, we are not going to use a parameter, so we are not going to use method 3. We are going to stick to methods 1 and 2. Alright, so let's go ahead and bring down our equation for x, and then we'll bring our equation for y as well. So which parameter t is easier to isolate, in the x equation or the y equation? Well, the t in this equation would be easier to isolate. However, it's oftentimes better to use the x equation to isolate t because eventually you want to get y equals a function of x. So let's go ahead and do that for this equation. Let's isolate t. So our first step is to get rid of the square root. So to get rid of the square root, we're going to square both sides. The left side will be x squared, and the right side is really nice. The square root and the square just cancel out, and we get 2t. All right, we're almost there. We want to isolate t, so we need to get rid of this 2. So we divide both sides by 2. The 2's cancel on the right side, and we're left with t squared, or I'll say t. So t equals, so I'll write the t on the left side, and I'll say 1/2 x squared, which is really x squared over 2. All right, so now we've isolated t in our x equation, which is great. So now we're going to plug that into our equation here for y in terms of t. So I'm going to take this guy, so I'll go ahead and circle it. So there's our t value. We're going to plug it in right here for t. So this is going to become y equals negative 1/2 and then x squared minus 3. Okay, so there is our equation in rectangular form, eliminating the parameter. So do you by any chance know what this graph looks like? This here is a parabola because we have a x squared or a quadratic equation. Okay, so now let's go ahead and graph this. We're going to use our t chart here to graph. I'm going to erase this chart here so we have room to work with. Let's bring up our chart here. So here's our chart. Now we want to plug in specific values of t that would help us. So because there's a square root here, we want to plug in values of t that will give us a perfect square. And we also have a restriction on t. T has to be greater than or equal to 0. So we can't plug in any negative t values. So let's plug in 0 first. So if we plug in 0, plug that into the x equation, well, that's 2 times 0, which is 0. The square root of 0 is 0. So our x value is 0. Plug in 0 now for t here. Negative 0 minus 3 is just minus 3. So our first point is going to be 0 minus 3. Next, we want to plug in a value for t here that will make this a perfect square. Now, a really nice value to plug in is actually 2, because 2 times 2 is 4, and the square root of 4 is 2. So let's plug in 2 next for t. Plug that in for t here. 2 times 2 is 4. Square root of 4 is 2. Plug in 2 for this t. negative 2 minus 3 gives us negative 5. Okay, what's another number we can plug into t here to make this a perfect square? Well, if this was 16, that would be a perfect square, so I'm going to plug in 8 for t. So notice we're being pretty strategic about what t values we plug in so that we can get a perfect square. So the square root of 16 is 4, so our x value is 4. We'll plug in 8 for this t. Minus 8 minus 3 is minus 11. All right, so now we have 3 points on our parabola here. So let's go ahead and graph. So our first point is 0, negative 3, and that will be right down here. So we'll start at 0 and we'll go down 3, so right there. Okay, next point is 2, negative 5, so we go right 2, down 5. So that's like right there. All right, and the next 4, negative 11. So we go right 4 and then down 11. So that's about, this is negative 9, so 4, negative 11 is probably about right here, we'll say. All right, so notice this looks like a half parabola going down and to the right. So it starts here, because remember, this is our first point on the graph because they tell us that t must be greater than or equal to 0. So we're going to start here, I'm going to go down and to the right. Okay, so this looks like this here, down and to the right. Okay, and then since our point started here and then kind of kept going to the right as t got bigger or increased here, that tells us that the orientation or direction will also go down and to the right. So I'll draw some red arrows there. So our orientation or direction goes down and to the right. So here is our rectangular equation of these two parametric equations, along with a graph that describes it with the direction noted by the red arrows here. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.